on in the next session, we'll go deeper into artificial intelligence, and it'll talk about artificial intelligence in the platform economy. And I'd like to call the panel on stage, and this panel will be moderated by Albert Eng, who's a strategist at Comtrade Digital Services, and he joins us from the United States. Albert is also a specialist in mergers and acquisitions in fintech and AI. He advises C-suite executives on how to acquire leading-edge IT capabilities via acquisitions, joint ventures, and partnerships. And I'll leave Albert to introduce you, the panelists, and looking forward to hearing an interesting discussion on AI.
Is my mic on? Oh, it is. Good. All right. How are you guys? We're the last... Hopefully not the least but not last, so to speak. How's your energy? Is it kind of okay? 5 o'clock, you're still here. I'm from the U.S., so I actually have something to ask you off topic because it's just been eating away at my thinking for the whole day, and I can't move forward without getting the answer. But was the Conor McGregor-Mayweather fight stopped too early? Raise your hands if you think so. Oh. So you thought it was stopped early enough. And was, if Mayweather was in the octagon, do you think he would have lasted 3 rounds or 1 round? 1 round, raise your hands. Okay, 3 rounds, raise your hands. Okay, well, it looks like, guys, most of you didn't watch the fight. All the better because it was just pure money in the hands of their pockets. But anyway, I digress. I want to try to make sure that we have enough energy to give to you so that you're listening and being provocative and asking us questions. I've got a star-studded cast here, and I'm really excited to be here. This is perfect timing because this is also describing and giving us a launch, if you will, to Comtrade's own investment in artificial intelligence and our commitment to being involved and tapping into the insights of thought leaders like our panelists here to give us wisdom around how our product, services, offerings, and capabilities should be shaped for the future as well. So, with me here are very distinguished panelists, all in the area of AI. And I'm going to make really short introductions and then ask them to give more formal introductions. But first off, I'm going to ask you another question. Have you guys seen Particle Fever? No? It's on iTunes. It's about CERN. So with me here is Fons. I will not say your last names because that way I won't butcher them. But Fons is like the isotope at CERN. He's one of those leading isotopes that causes, the collider to work. So Fons will be able to tell you all the things that are going on at CERN. I have Marko and Robert, professors at leading institutes and in universities that I wished I would have had as a professor when I was going through my school. And of course, we have Vincent from IBM, who's going to tell us all about AI and what IBM is doing. So that's where we are today, all right? So my first question to the panel, and we're going to start from Fons all the way to Vincent, is to first give a more detailed overview of your background, to talk a little bit about your organization's use of AI. What were some of the decisioning criteria and the hurdles that you had to overcome?
My background is in data analysis, massive data analysis programs. So we've been developing since begin 90s the programs that are being used to analyze the data coming from the large detectors in the LHC. So that's currently we are around 600 petabytes of data has been recorded and is being processed, all in a project that we have developed from scratch. It's all open source, and that can handle this kind of amount of data. And it works from storage, vertical database storage, sequential storage, to analysis, all the mathematics there, all the fitting, all the neural networks, multivariate analysis, all the graphics to make any scientific plot in any format you can wish or imagine, and to make it publication ready. So any plot you see in any high energy physics publication is made by this tool that also was used to store and retrieve the data of the experiments. So this is a whole one tool that uses this basically takes care of the data from in the whole life cycle. So having said all this, data analysis in physics is based on algorithms of that implement the physics processes described by theories, and some of them go very fast, some are very time consuming, and now we start using the latest AI techniques, image recognition, where in principle we have not that many images, but in some detectors we can create images where we have calorimeter, cells are hit, it's a kind of color plot, and the type of cells that are hit and the configuration of the hits you can use to train using the visual artificial intelligence algorithms to be much faster in classifying that these what happened there were certain what type of particles caused this pattern to light up. And in that sense, well training and artificial neural net turns out to be much more efficient than the full algorithmic process. So we can always do it in the full algorithmic way, and the neural net helps us to speed up tremendously some of those processes. Now to go further and go away from using the visual AI, we're working on that, and just to see how much better it can be. It's a huge learning process also for the physicists who are, many are statisticians and know all the latest statistics methodologies, but they have to learn how to best use those neural nets.
Did you find the challenges? Were there many challenges in instituting your first version of AI?
No, I mean physicists are, they just try everything they can try. So they, when TensorFlow came out, they tried that. We have an own implementation that we benchmark against all the industry things that come out. So we're always happy if we can still beat them and be better. And so we keep using many of our own algorithms in our industry and improving them. And good for you, they also like TensorFlow, all open source. So you can find them back if you start looking for them. So that's how we keep, both parties, all parties honest to see, who makes the best progress.
Did you have a QA function?
No.
Okay, well, that's why, right? So it'd be interesting to investigate.
But, yeah, we have the real physics.
Right. Okay, thank you. Robert?
Well, sorry, is this on? Yep. It's difficult to follow up on that if you're not working in CERN with high energy particle physics, but what at least I lack with the depth in that sort of area, I'd like to think that maybe I can offer something in terms of the variety of projects I've been involved in that might have some relevance for you. So my name is Robert Ross, and I'm a senior lecturer, or in American terminology, a professor at the Dublin Institute of Technology. And my research interests are very much around areas of machine learning, interactive systems, which all taken together are commonly artificial intelligence, and I'll come back to my thoughts on that term itself in a few minutes. So I did my PhD over in Germany. Interesting, though, maybe for some of the people here, my PhD topic, or at least the group I was working with, were very into reliable systems, safe and secure systems, and we were looking in particular at autonomous vehicles and making sure, or trying to make sure, that these things would have a level of intelligence, but yet not career into walls or off cliffs and so forth. So, we very much in our research group had this continuous friction between the goals of developing smart systems that could help people, but that counter flow where you want to make sure that they're smart, but yet contained. That they're contained in a way where, and relating back to the points earlier, they're reliable systems, they're trustworthy systems. And I think one of the big and interesting questions for AI as we move forward is that question of how can we maximize the intelligence, the originality of the systems that we're dealing with, but yet be able to trust them. It's a simple problem. And I think we've all read the stories of, autonomous cars getting distracted because there was a particular light input and they then deviate from the original plan. One thing, just in terms of my own background, I'll mention as well, is that the reason I'm here today is that I'm not just a random academic, but I'm involved in 2 national research centres which have a very big focus on working with industry. So I have a lot of experience working with companies and the particular needs of companies. So for those living in Ireland, one of those centres is the CEDAR Centre, funded by Enterprise Ireland and the IDA, and the other is the SFI-funded ADAPT Centre. And both of these centres, they're heavily involved in data analytics and artificial intelligence, and it's a big part of our remit, not just to do PhD-style education, but also to go out and work with companies, be that in terms of contract research or also in terms of this deleveraged research where companies maybe pay 20 or 40% of the research costs, and there are various government models that work around that. Now, I just say all of that not as a sales pitch in particular, but just to give you an idea of where my thoughts are coming from when I talk about AI and data analytics and when we put it to work. So I think some of your question, beyond just a self-introduction, was what sort of challenges have we had in deploying AI to our systems? So obviously, since we're a research centre, we're not just developing one or two individual systems, but instead working with companies to develop lots of different types of systems for lots of different environments. But what I can tell you is, looking across all of them, I still think two of the biggest challenges we face are still issues around quality of data. It's still a fundamental problem that in many tasks, unless we're looking at something nice and clean, like image recognition or speech analysis, if we're actually working with real companies with real data from real companies, and where that data is sometimes structured data that's spread across different silos within the companies, it can still be very challenging for us to get the companies just to figure out what on earth their data even is and the quality of that data. The second challenge, and related to that, is trying to figure out with companies exactly what they're looking for. Because I think at the moment, particularly in industry, there's a very big push for artificial intelligence. We all know we need artificial intelligence, and we need it right now. And I've literally seen and spoken to students who are graduates of ours who have been hired as data analysts or data scientists. And we've spoken to them at, say, graduation, how are you doing, John, Mary, are you doing well? What do they have you doing? And these recent graduates are literally turning around and saying, I was hired as a data scientist, but they don't know what they want me to do. They've just heard they should hire some of us, but beyond a couple of key companies who really know what they're talking about, by and large, people are just pointed at the data warehouse and told to go discover insights.
Perfect. And then with that thought, that's a great thought. We're going to investigate that one. I heard one word that resonated with me when I heard Robert and Vincent talking earlier, and that's trust. And what does that imply to develop trust in a system? Quality assurance, maybe? So let's get into that in a little bit more depth, okay? Marko, if you could.
Okay, thanks. Thanks. So I'm Marko Robnik-Šikonja. I'm from the University of Ljubljana. I'm professor there. And artificial intelligence actually has a very long tradition in Ljubljana. We had artificial intelligence lab in 1970s. So we have seen artificial intelligence, machine learning, intelligent data analysis, deep learning, and all those buzzwords come and go. So it has been artificial intelligence winter, now it's summer, but actually things which are permanent, which do stay, is that the technology is improving slowly, and it's getting better. And as was already said by Robert, it's hype now, but it doesn't mean that it's unsubstantiated. There were things which were discovered new, and I'm really excited about them. But we have to be, we have to be realistic. There would be winter as well, right? So maybe I can tell you a few things what we really do in University of Ljubljana, what we do really good and better than others. For example, we have a really good tool for bioinformatics, for analysis of genes. It's called Orange. It's one of the best tools around in the world. It's included in the Anaconda, for example, and almost an industry standard in that area. Then we really do lots of, for example, visual tracking. We have a group which organizes annual competition, challenge, and all the best groups with video trackers come to our university, and then we have like, I mean, the guys from university, they compose really like a super model, which is the let's say, takes all the good stuff from the individual solutions. And the third things maybe which I want to mention, now when you were talking about trust and quality, well, trust also presumes understanding. So AI is just not, it's just not good enough that it's a black box, because we know that there will be biases. If we will learn all our cats and dogs on the black cats, AI would just learn to recognize black cats, not cats in general. I mean, there have been cases like this. So biases are hidden in the data, and we don't know about it. That's why we need understanding of the models. So one of the things we do really good, I mean, we have invented a couple of, let's say, model explanation methods, which can, for a given, let's say, classification, can explain why this classification happened. For example, in a medical, if we, for example, predict that, for example, this patient is going to have recurrence of cancer, then it can tell us, so these are the factors which are in favor of that recurrence, and these are the factors which are against that recurrence. Or, for example, for an image, if you have an image, then that methods can, for example, point out the areas on the image which actually explain what's the difference between dog and the cat, or I don't know, whatever you are trying to do. So basically, yeah, that's it.
Great. Well, Vincent, we've had your bio, and it's a very good one, of course. Laura, you described it. So instead of asking for your overview, actually, I want to change the topic around our view on the platform economy as more as it relates to AI platforms, actually. So from the standpoint of open source and proprietary AI platforms, let's take an example like Watson. So what's the deal with Watson, and why should we move to Watson, your sales pitch, as opposed to open source?
Okay. Well, let me first say I work at IBM Research, and
right.
So my job is to develop the technology, not to sell the technology.
Then let me rephrase my question. Which AI platform would you use?
I've used a few different ones.
Okay.
So in our development, we actually do use a lot of open source software. So that includes things like Theano, like Caffe, like TensorFlow. I mean, we as researchers, we use that.
Right.
We use those tools. And as IBM, we also want to contribute to open source projects. Because with purely proprietary technology, it's very hard to keep up with the pace that some of these
right.
open source libraries are
Yes.
progressing with.
So, Fons, your view on open source, and what has CERN done to contribute to open source in the communities?
Well, the tool that I described is about 3 million lines of code, and it's free downloadable, so we contribute to that. We test, for example, the storage element is tested continuously against all the current open source ones, Hadoop, Spark, Parquet, all the storage elements that are now being developed in Apache Foundation and other ones, and ours still handily beats in basically everything, in performance and in compactness and in features, all the hype tools. So our problem is that we are very bad in public relations, so we developed it for our community, kept it in our community, discussed it and used it in our community. We never went outside into database conferences or workshops or whatever to publicize what we've done, like database guys would do. And that is the same for the tools that we have available for all the analysis and the machine learning that are part of this very large toolkit.
So that's an important point. One of the things that we're doing as part of our launch in our AI practice is that we're going to be able to help you access the open source communities, and we'll have catalogs, indexes, and people that are knowledgeable about the open source platforms for you to call and learn more about. That's part of what we're planning to do for Comtrade, to our customers and to all of you. So hopefully we'll have a nice view on all the open sources available at CERN that you can access in the public domain as well as at IBM. Marko, do you have a view on open platforms or proprietary platforms?
Yeah, sure. I mean, as researchers, we are basically paid from the public money, and I think it's only fair that we actually put those platforms and the software we develop back to the communities. And there's really a huge, there is actually open source and open source. There's really huge differences in quality. I believe that what CERN does is probably very well tested, but it's not the case for all the software. So as a software developer, you actually have to be really aware that, what you are getting into. So there are huge differences in quality, and maybe AI can help you in that respect as well, because I've seen lots of research done on, for example, on data mining, for example, metrics, software quality metrics, and for example, data mining the structure of the programs to detect, for example, anomalies or for example, predicting problematic points and stuff like that. So there's been really lots of research, and with deep learning, this is just increasing, because these deep learning approaches are actually better at figuring out what's the structure of the programs. So actually, deep learning shines actually on natural language. So it can really, as was shown, it can really detect or recognize the sentences. So it can also recognize the artificial languages as the program languages are. So this is really a huge opportunity, I think, which was not discussed today.
Great. Thanks for that. So Robert, you talked about trust. Now let's get into that a little bit. How do we introduce the QA function that's very well understood in traditional software development? How do we introduce that in AI engineering? How does that work due to the recursive nature of AI development and the algorithmic iterations that are so much more frequent and interactive with the business community?
Frankly, it's tough. Frankly, it's going to take a fair amount of work, particularly because those who are working in developing the AI type or AI-based techniques are often, as with Vincent and some others and people I work with, they're working in an R&D component of an organization usually. If the organization is sensible, they have sandboxed in the R&D division. They have made sure that they don't have exposure to live data, and they've made sure that, even from a network perspective, that everything's closed off. But that's fine when it is the R&D component. But when we talk about trying to take techniques, which I think we have then established in the development or the slightly research and development environment, and bring them into the mainstream part of the organization, that's when these issues of the quality assurance process are really going to have to kick in. So, and I'm answering this question from the perspective of applying AI-type models into products, and be them sort of classification models or regression models and so forth. And I think if you are talking about those types of AI models, then fortunately, though, we can start looking at the testing process as a normal testing process to some extent. It is about boundary cases. It is about creating conditions that we hope will still be acceptable to the algorithm, and we can check that, but then also doing estimates of where we think the algorithm might break and testing that. The one worry I always do have, though, is that while we can set up these boundary cases and start to put in levels of acceptability in terms of the quality of service of the algorithms, it doesn't mean for sure that there aren't variations that we've missed. And that's where I worry. That's what stresses me. That's what keeps me up at night. But I think it's a direction that we're moving in, to say that, yeah, we still need to treat our sometimes black box, but sometimes white box type algorithms as a software component that needs to be tested and validated and investigated in the same ways we would treat anything else, and not get tempted just to treat it like some sort of god that we just trust.
Is there anything else to add, guys, to Robert's remarks?
Well, there's a couple of things I'd like to contribute here. So, one is the perspective which you mentioned, that AI algorithms, or let's call them machine learning algorithms, just to be specific, can be very complex. There's this great quote from one of the researchers at Google, I think it was Ilya Sutskever, who said, deep learning is easy the way rocket science is easy, right? It's easy to understand why the rocket goes up into space. What's really hard is all the little engineering details to make the rocket work. And one of the things we want to do at IBM is actually make things like machine learning, like deep learning, more accessible to a wider group of people by simplifying the interfaces. So in order to be able to use something like machine learning as a tool, you don't have to know about all the little engineering details, but you can focus more on the application, which also leaves you as an organization with more resources to go focus on things like quality, testing, and finding out what the corner cases are. So that's one aspect. And then the other thing Robert mentioned was, well, you shouldn't treat the AI as a god, right? You should figure out how you can actually still test that it's behaving the way it's supposed to be behaving. And with learning systems, this can be hard because these learning systems evolve over time, and so the output you get for a given input is not always the same. But this system, from a statistical perspective, should still reach certain benchmarks. So rather than to give it just one input, maybe you should give it 1 million inputs and make sure that on average it still reaches all the benchmarks that you know it's supposed to be able to reach. So those are...
Right.
Maybe I can just add that one of the definitions of intelligence is that when things get complicated enough, they emerge as intelligence. So this is maybe, unavoidable. When you want to plug into artificial intelligence or machine learning, whatever, into your system, it's going to get much more complex. And it will, of course, it will bring new problems. And whenever you have learning, learning means changing. And the system will change, the system will be different. When they were yesterday, they will be outdated. But I think that's not bad news for the software industry.
Right. So, one of the questions we're going to ask is about career paths for QA engineers and where that can lead with the advent of AI. Bit of advice: the person or persons or group that solved this problem on how to provide adequate QA methods into AI will be the ones sitting in Monaco on their yachts. Okay, so that's one piece of advice and sorely needed thought leadership around that. Data, as it implies neural networks, data will now move to neural networks. They'll be stored in neural networks. So the question to the panel is, tens of millions of dollars invested in enterprise data warehouses, hundreds of millions of dollars with people trying to analyze and build MIS reports around that. Business process generated data. And now we've got this big data phenomenon, which includes human-generated data through social networks and device-generated data from satellites and wearable technologies. So the question to you guys is, do we just throw away the enterprise data warehouse? Is it completely obsolete at this point? And if it isn't, to what extent do we have to renovate the data warehouse so that it can actually be useful for our AI? Questions or answers? I don't have the answers. That's why I'm asking you guys.
Well, I have no idea about the business environment in that sense. I only know that we don't store data in artificial in machine learning. I mean, the data is still the data as it is,
okay.
And the data warehouse or our data store still will provide the data to the algorithms, the machine learning algorithms, or the direct analysis tools, and nothing will change there. And in our case, even thinking about converting more than an exabyte of data from one format to another format can not even think about it, because you have your backups, all that in the same format. So any solution has to work on existing data store. So if you think that you come with an AI solution that requires the company, or the organization to change in another data format, I think mostly you will be dead on arrival. In our case.
So that's great insight. But often we've heard about data having to be reclassified, reprepped. Perhaps Robert and Vincent, Marko, you have other perspectives around the effort of conditioning data for AI also. Yeah.
I'd have a perspective on that, all right, because I think in general I would be also of the opinion that the data warehouse is not going anywhere. That's needed, that's there. Companies, enterprises invest a lot of money in setting these up, maintaining them. They have valuable business data. Yes, it's not that huge, big data coming from social media or Internet of Things type streams, but it's valuable transactional business data from the enterprises or government organizations and so forth. And we can still do interesting things with it. Now, it's not the sort of data or the sort of interesting things that really necessarily push AI to its absolute limits, but nevertheless, we can still do some really interesting stuff with it. But yes, often is the case that the data that's there could be improved. The quality of it could be improved. In some cases, if people want to do interesting tasks, labeling of the data could be improved. Figuring out different relationships between the data that's already stored there across different silos of an organization. That can all be done, but that all, as mentioned here, then feeds into just improving the data store we have that we can then apply, be it to traditional machine learning algorithms or the deep learning algorithms or anything else, and indeed to then combine it with other unstructured data that maybe is stored in the company's new NoSQL database and so forth. You know, there's great possibilities there, I think. But I don't think we need to throw anything out just yet. Yeah.
I agree with you. I mean, you will add maybe new structures to the existing data for the new analysis you want to do on that. So you'll expand a bit your data, but in no means you will get rid of the existing.
Yeah, maybe if I just add that actually in machine learning you would need like pretty much pre-processed data, clean data, and it's like an estimate that approximately 50% of time and money for a data mining project will go into data preparation.
So I have a couple of thoughts on this. So first of all, generally, no, I don't think the data warehouse is going to go away, but it might look a little bit different if you think about several years ahead. But this is not necessarily true for everybody. So first of all, some of the really big success stories in machine learning, especially the deep learning field, are cases where there was an absolutely massive amount of data. So internet scale data. But other than a few large companies, most companies don't have internet scale data. And a lot of companies actually have a problem that looks much more like we don't have enough data to train our super fancy algorithm, rather than we have too much data and we don't know where to put it. And so that's also one of the things we're working on at IBM, to try to help people build machine learning applications when they don't have quite that much data yet. The other thing I wanted to comment on is, well, suppose that you do have a lot of data. Suppose that you do, in fact, have these massive amounts of data. Then you do need to kind of rethink a little bit where you put that data. Because the architecture where you have all your data over here in a warehouse and you have all your computing power over there in some sort of big cluster, that doesn't work. Because now you have to go, every time you process it, you have to go send that data over a network. So maybe you want to redesign the system in such a way that you co-locate the data storage with the data processing. But that's when you're really talking about like.
That's a great segue to my next question, actually, for Fons. Can Fons, can you give us a bit of an opinion about Hadoop versus EOS? EOS is CERN's file management system, and sort of, the contrasts.
Well, I mean, of course, all our data is stored in, one copy of all the data stored at CERN, and then there are 12 centers worldwide that store each 1/12 of the data, and that's the custodial data. Then when the scientists are processing the data, they are processing data, creating new data on their local environments, on their local disk CPUs, for further processing there. And then the the raw data that they want to access, or their new data they can put back in a system we call EOS, which is a distributed file system. Grew out of our own development, our needs. It's also freely available. Comtrade is handling packaging this, so that's how we got in touch with them as a project. And this is a remote file system where via file catalogs scientists look up which files they need from the metadata, and then those files will be typically over the network brought local for local processing, reduction, new type of new processing, and further analysis. So that's how we typically work and have this all available.
Why not Hadoop?
Because it didn't exist when we started.
Would you have?
This, and then, so we think we're still pretty good with what we do.
Great.
And Hadoop is, it's all, very efficient C++ and all that, and not slow Java. And also because the language is not really that important, but when now we get very fast memories that go as fast as, SSDs almost as fast as RAM, the language becomes an issue. And, Java will become a bottleneck at a certain moment. That's for a later stage, not in this, but you have to think about all those things, and you don't want to have, we have to ask our funding agencies, hundreds of thousands of CPU cores to process the data. And if we would tell them that we need 100,000 more because some people like to run Python on it, they of course tell you to get out of the room as soon as possible and only use C++ and not waste a single cycle with a slow language that might be more convenient for somebody who is too lazy to learn C++. So I mean, we have no argument or discussion. Any physicist comes in, learns C++. And universities provide Python, so they have to have a little bite, a bit sour grapes, but that's it. And after that, they are happy.
So that brings me to my next question. Okay, and each one of you, and then I think we have enough time to offer some questions to our audience here. Your perfect AI sandbox, Robert, what would it consist of? What tools, which open source platform or proprietary platform would you choose? What would be your perfect AI sandbox development environment?
Is a very tough set of questions, actually, because I will give you an answer to that, but let me preface it by saying I'm just a great believer that students / staff / anyone who wants to learn stuff should get exposure to as many different platforms and technologies as possible. And absolutely from when an organization has particular constraints, hundreds of thousands of computing nodes needed, for example, then imposing restrictions are, of course, very well justified. But as a rule of thumb, as an educator, it makes sense for people to get as much exposure as possible. So, but all of that said, I think if people are sitting down to get to work in this sort of area, there is a lot of argument for saying that people should go down that whole Pythonic route of things, simply because development for individuals while they're trying to learn things can be very, very fast. Many people will criticize Python, and rightly so, for various features. I won't get into the technicalities here, but the sheer support in terms of different libraries, things like the sklearn for basic machine learning, things like TensorFlow for doing deep neural networks and so forth is vast. There are huge communities online with people really willing to support these technologies. And if you're sitting down and you're in a company and you're trying to figure out how to put these ideas, machine learning, AI, to work, then setting that whole Python Anaconda type environment up and going for it is a really good way to go. But what I would also like to do, and I shall do this as a favor to my colleague here from IBM, is say that there is also something to be said for organizations looking at this whole growth in, let's call it AI as a service. That it's not always just about running the technologies on our own servers and doing the code ourselves, but there has been, in this past year in particular, beyond Watson, so in this past year, there's been this huge growth in the idea of APIs coming online that are delivering AI-type techniques to people that they can subscribe to, they can pay a subscription for, and importantly, engineer them into complete solutions. And I think that market is going to, it's already growing rapidly, and I think it's going to continue to grow at a huge rate, and I see nothing wrong with that. It often will lag a little bit behind the real cutting edge stuff in the open source environments, but nothing wrong with it at all in my view.
Marko?
And there's definitely a trend to make machine learning and AI into, let's say, Lego blocks. But these Lego blocks at the moment are a bit fragile, right? So that's the reality. So in general, I mean, you just we should be pragmatic. I mean, just take what you need, depending on the needs, what you already said. For example, for us. We do develop new things, we research things, so often we write our own code. It's mostly in C or C++ for the efficiency reasons, but mostly it's linked with R or Python to get the front end.
And Vincent, your view?
So I have a few thoughts on this. So first, let me try to answer the actual question you asked, and then maybe a few questions that you didn't ask. So in terms of the ideal tools, it depends on what you want to do, right? So if you're a student and you want to learn, then an open source tool is great because you can really go dig into exactly how does it work, and if there's ever something where you don't know which particular algorithm is being used or which optimization strategy, you can just go dig into the code. You can find out all the answers are there, but it might take you some work, right? Not all of this is equally well documented, and so you're often on your own in the sense of support from the product, for lack of a better word, but there is a great community, right? So that's another great benefit from open source software. There's often thousands and thousands of people working together to improve this software and answer questions. Then again, if you want to build an application, so if you're a young startup and as part of the product you're offering, you need some simple speech recognition or you need some image recognition, then there are pre-built options available for you, right? So all the major companies are offering these kinds of services through the cloud. So IBM, Microsoft, Amazon, Google, everybody's getting into this game. So that's kind of maybe the answer to which tool should you use. It depends on what you want to do. But there's one more thing that I wanted to bring up, which is that there's a lot of hype around AI at the moment. And I don't know about you guys, but I feel like every week somebody comes to me and says, you know what, you have this really important business problem and you don't know how to solve it. Nobody knows how to solve it, but don't you worry because I have this AI and it's going to fix everything. And I think one of the big challenges for everybody now, I mean, it used to be just the machine learning community, but I think now everybody gets exposure to this technology is, well, how do you tell the difference between a promise that someone will actually be able to deliver on and something that is more like a sort of aspirational or hopeful goal that they one day hope to achieve? And the people that really want to learn how to tell the difference between those things, I would say, go try to build a machine learning algorithm just once. And you will see how hard it is. And then suddenly you'll be a lot more skeptical when somebody comes in and says, oh yes, my AI solves all the problems. Because you realize the gap between kind of seeing that it might work and actually making it work.
Great insights. One last question. Career advice for the crowd. 30 seconds each.
Career advice. Well, the most important thing is to be enthusiastic about your job, learn a good language, and of course play with many to understand why and what are the differences. And just, if you like doing this, then you should do it. But don't do it for the money.
I'm an educator, so I'll be a bit biased here. Never stop learning. And when I say never stop learning, I just mean applying to understand new tools, So avoid getting stuck in a rut. But it's not just about, and here's a key thing I think for many people working in the software industry, while many engineers, particularly recently, can get away with cutting and pasting solutions from Stack Overflow to try to generate something that seems to do what they expected, there is no substitute for practice and quality. Coming to the conference, yeah.
Aren't you offering courses here in the area?
Oh, yeah.
Just
courses are one thing. If anybody wants to pay me to teach them personally, that's even better. But, it is about improving that craft, making sure that craft is at the highest level that it can possibly be. And I think big employers or small employers or anybody who's looking for quality will recognize quality. And we only get that through practice, practice, practice.
Well, a hard question. I will be short. Just expect the unexpected.
That's a good one. And Vincent?
Well, when you asked the question, the first thing that I thought was never stop learning, but then Robert already said that. So first of all, let me say, Robert, I totally agree with you on that. I can also talk a little bit about my own story. So I actually did not study computer science. My background originally is in physics. So Fons, we can chat particle physics later over a drink.
Watch Particle Fever. Are you in the documentary?
No,
Oh.
I know the people.
Yeah, okay.
But now I'm actually working on deep learning at a tech company. And the way I got there was through curiosity. So I did not originally think that I would end up working on deep learning. I got interested in this because of some of the academic breakthroughs that I read about. And then I thought, I should read a little bit more about that, which was initially purely curiosity driven. And that ended me up in a career doing this for a living. So in addition to saying never stop learning, I would say stay curious.
Great. So we have 7 minutes. I urge you, you're not going to see these 4 guys in one place other than here right now. So ask some questions. Anybody? We have a, Oh, you got one? Okay.
I have one question. There is the whole field of static code analysis. Do you think that AI can be applied to it? In the moment of the static code analysis, there's a lot of tools. You have to put a rule, several rules which are actually given by people, and then you run all, the analysis on your code. It can take sometimes a lot of time, maybe hours, and in the end you have a lot of false positives. Do you think that there is a place that can apply artificial intelligence there?
Go ahead. So I think, Marko, you already mentioned that one of the places where neural networks have been very successful is in language processing. And so computer language is also a language. So in that sense, I would say there's a big potential for neural networks and machine learning to be applied to that language. But let me also apply my own advice to myself and distinguish between, this is something we know how to do, and don't worry, next year we'll have a little box that does that for you. And the more aspirational goal of, it looks like we have the right kind of tools to work on that, but it might be a while before we really solve the problem. And also, I'll bring up again the thing I mentioned about accuracy. So I think that things like code analysis are applications where a machine learning algorithm can be useful, even if it doesn't catch everything, right? Because often you end up having to analyze hundreds of thousands of lines of code, and if the machine learning algorithm can just give you a list of maybe only 100 places where a human should go and check that maybe that's okay, you can still get value out of machine learning, even though you don't catch everything, because saving you some time is still valuable, even though the problem is not entirely solved.
Yeah, I agree with that. I've seen applications of AI in that area. Some of them were successful, some weren't. But in general, I would say whenever you have like something where you can collect some data and have some evidence, well, it's worth trying.
Any other questions?
Hi. So basically, my question is, what you see is a coming trend in industry. Okay. So there has been an era of computers, then came the era of internet and Google, and now it's the era of Apple, for example. You don't have to be smart, you just have to be out there. So what do you think from your perspective, what's coming up for us? People say it's robots and AI. Now you also say that we are pretty far away from that. So what's the big thing that is going to come right now and what we should be prepared for?
Maybe I can answer. There was actually a quote from Niels Bohr, which was a physician, and he said, prediction is very difficult, especially about future.
I think if we could accurately predict that, I'd be on that beach in Malibu or something, or off to the Seychelles very soon. But let me instead answer where I think I would like things to go. So I think in terms of big technological changes over the next while, I think we will see a lot more in the area of the autonomous vehicles. We will see more in terms of intelligent personal assistants, which will very much give the illusion of intelligence, glorified chatbots that are properly linked in to various information sources that are connected into the recommender systems that are interacting with and monitoring your personal information. I think we'll see that all being done. That's all pretty much inevitable because that's where Google and IBM and Apple and everybody are investing so heavily. You just have to look at Alexa and see the direction that's moving into. But where I would personally get far more excited, and this comes back to getting away from pure computer science and getting back into the physical sciences. I too have an undergraduate degree in physics, is human-brain interfaces and different modes of interaction with computer systems. I think that's a big place where things will change over the next 10, 15 years. We're very much moving into a direction where we're not talking about computers reading our minds, but that ability to sort of have a level of control in sophisticated interaction is something that people are exploring an awful lot with. And actually that's a very important area for deep learning, where people are trying to interface tons of data about how the brain processes and trying to mine that based on collecting huge amounts of fMRI type information. So that to me is a big exciting area. I would hope to see things change.
Maybe a few more words. I mean, with deep learning successes, actually we got a sort of a vision box and a sort of a hearing box. So where now we have a problem which will require sensors, visual sensors or hearing sensors, we can expect that there will be some development and some progress in that area.
I have two predictions. I believe that we're seeing all of what you think will be in the future now. It's now velocity of maturity, and you just got to stay on pulse with the latest developments with the big IT houses like the Googles, Apples, and Amazons of the world to see how they're leapfrogging over each other and doing the same kinds of things. I do feel that Internet of Things, being able to capture, manage, and understand the information coming from all the devices is the next frontier, and then to bring that into the machine learning. The second prediction is I think this guy's going to invent a wormhole, and I think we're going to be able to know how to use that to travel without getting jet lagged between New York and coming to Europe. That's what I think. Yeah. At 6 o'clock, do we stop? Or, first off, I want to give you guys a round of applause for the energy that you have for listening to us. All right.